Right, so next topic is CC15. Again, this whole topic is highlighted, and the main cause for concern in this one is the calculating whether a reaction is endothermic or exothermic. And for the most part, it's straightforward. What you're going to do is you're going to look at the energy required for bond breaking, and you'll be provided with a table with those values. You calculate the energy required to break all the bonds, and then you looked at the energy released when the new bonds are formed. And at the end, you'll do reactants minus products. And if your answer ends up being negative, then you've got an exothermic reaction, and if it's positive, you have got an endothermic reaction. And in general, people are okay with that. But what happened in the mock is I gave you this reaction, and a number of you struggled to draw the molecules. I mean, you can't draw the molecules. It's very difficult to see what bonds are being broken and what bonds are being formed. Sometimes they give it to you. So I've got an example here from the booklet where they've drawn the molecules for you, and it becomes a lot more straightforward. But if they don't draw the bonds for you, you're going to need to be able to do that yourself. Just want a quick recap, some kind of hints when it comes to drawing these covalent molecules, because they'll always be covalent molecules. So because I'm looking at covalent molecules, I've just got groups 4, 5, 6 and 7, so my non-metals, and I've also got hydrogen. I haven't included the noble gases because they don't form bonds. They've already got their full outer shell. So if you've got a group 4 element, group 4 elements need another 4 electrons to have a full outer shell. Because they want 4 electrons, they will form 4 bonds. And your classic example there is carbon. Forms 4 bonds because it wants 4 more electrons to have a full outer shell. If you're in group 5, you've got 5 electrons in your outer shell. You want 3 electrons more, so you're going to form 3 bonds. So nitrogen's your example there. It forms 3 bonds. So CH4, I'd have NH3 is ammonia. Next one, group 6 electrons in your outer shell. You want 2 electrons, so you form 2 bonds. Oxygen's your classic example there, H2O. And then in group 7, you have got 7 electrons. You want 1 more, so you form 1 bond. I'll go for a period 3 element this time. Chlorine would be HCl. Hydrogen has got 1 electron in its outer shell. It wants 1 more to give it a full outer shell. Remember, its outer shell is the first shell, so hydrogen will form 1 bond. You'll see it there already in HCl, and you'll see it just forms single bonds each time. So using this information, it should hopefully help us draw out some molecules. If you know how many bonds the elements need to form, it will help you figure out what to put in the center and whether to be using single or double or triple bonds. So let's look at an example, CO2. When I'm trying to draw CO2, the first thing I do is I find the element that can form the most bonds. So I've got carbon in group 4, it can form 4 bonds. Oxygen's in group 2, it can form 2 bonds. So the element that can form the most bonds is carbon. So I put carbon in the center, and then I put the 2 oxygens around carbon. I know oxygen is in group 6, therefore it needs to form 2 bonds. This oxygen isn't bonding to anything other than carbon. So the 2 bonds it forms has to be to carbon. This oxygen is the same, and when I look at it at the end, each oxygen has 2 bonds, carbon has got 4, everyone's happy. If I have a look at drawing NH3, which is what I've got there in front of me, nitrogen forms 3 bonds, hydrogen only forms 1, so I'm going to put nitrogen in the center. I'm going to put the 3 hydrogens around nitrogen. Nitrogen needs to form 3 bonds in total. Each hydrogen can only form 1, therefore they're all going to be single bonds. If I was doing N2 though, on the other hand, I've got 2 nitrogens bonded together. Each nitrogen needs to form 3 bonds. They're only bonding to each other, so I'm going to have 1, 2, 3 bonds in between. So as long as you're kind of meeting this rule when you're looking at what you've drawn, that everyone has the right number of bonds, then you shouldn't really go wrong. But let's go back here to the example I had on the other side. So I've got CH4. Carbon's in group 4. It can form more bonds than hydrogens. I'm going to put it in the center. The 4 hydrogens will be around it, and I know each hydrogen can only form 1 bond. And then carbon ends up with 4, which is exactly what I want. And then I've got Cl2, so 2 chlorines next to each other. Chlorine's in group 7. It can only form 1 bond because it only wants to gain 1 electron, so that's going to be my Cl2. And then when I'm doing bond breaking, I'm counting up, and I've got 4 carbon-hydrogen bonds to break, and I've got 1 chlorine-chlorine bond to break. I'll use the table I do this calculation, and that's going to be my reactant side. Over here, this is the one that caused the most problems, drawing CH3Cl. So again, I'm looking at these elements which can form the most bonds, and that's going to be carbon. Carbon's in group 4, it can form 4 bonds. And everything else is just going to go around carbon. And then I look at the other elements and I ask myself, how many bonds can they form? Well, hydrogen can only form 1, hydrogen 1, and chlorine in group 7 can only form 1. And if I do it that way, carbon ends up with 4, so everyone ends up happy. And then the last one, I've got HCl, so I've got a hydrogen and a chlorine, working out what type of bond to put in between them. Hydrogen can only form 1 bond, chlorine can only form 1 bond, so I'm just going to be having a single bond. So I'm looking at the bonds I'm forming 3 carbon-hydrogen bonds, I'm forming 1 carbon-chlorine bond, and I'm forming 1 hydrogen-chlorine bond. And that's something that caused problems when we did this in the mock. A number of people didn't know what bonds were being formed here, so they ended up with the wrong answer. So please, again, do have a go at some of the other examples in your booklet. There's a few of them where I haven't drawn them for you, so practice drawing them yourself. Other thing that comes up in CC15 is just in terms of the practical, how you would do this experimentally. And you've got very simple apparatus here. You carry out the reaction in a polystyrene cup because the main source of error is heat loss. Put on a lid to prevent heat loss. You use your thermometer. What's the temperature at the start? What's your temperature at the end? And you work out if it's endo or exothermic. The other thing to note is here in your core content box, explain in terms of bond breaking and bond making why a specific reaction is endo or exothermic. Make sure you know that answer because it can be 3 or even 4 marks, and they are quite particular in terms of what they accept on the mark scheme.